and problem solving and vocab also. So we're taking a look at the next problem down on page 189. And here we go. So we have the solute NH4. So I need to find that curve. So I see NH4 and NH4, this is its curve. So I got to highlight it in yellow so I can see what I'm doing here. Okay, so what I'm told about the NH4 is I am given a starting XY coordinate. I have a mass and I have a temperature. So my temperature is 30 degrees Celsius and the mass is 35. So I'm going to make a yellow data point. So this is where this is happening. So this type of problem, I like to think about it as a problem. What I already have in solution, what needs to be there, and then what I do in the lab, what I describe. This would be like a part 2 answer. So what I know I have is I have 35 grams of the NH4Cl, and this is being added, or it's being held at 30 degrees Celsius. So this is where I'm starting. Boom. By the end of this, okay, no matter where my data point is right now, at the end, I need to have a saturated solution. But what also has to happen is it needs to be saturated at 60 degrees. So it needs to be saturated at 60 degrees Celsius. So that means that I have to, what's going to happen is that this solution, its original data point, heat is going to be added, right? So that's the heat, to raise its temperature. And as I raise the temperature, that data point is way below. I need to end up. So what it needs to be done is here. This is what's done in the lab. The temperature is raised. In order for it to be saturated, it means it has to be on that curve, right? So in order for it to be saturated at 60 degrees Celsius, it needs to have around 58 grams of NH4Cl. So the do part, this is like what's done in the lab. Or what can you do? So now you have a warmer solution, and now it's still well below its curve. So what do? Well, if you calculate the difference between the mass that we already have and what we need, it looks like we need around, so the difference is 23 grams of the NH4Cl. Well, what do we do in the lab? We actually add this to the solution. So 23 grams of NH4Cl needs to be added to the solution. So if we maintain a temperature of 60 degrees, we add 23 more grams, we will have a saturated solution. So this line here, this represents the mass added, right? Because we are going up to get to that curve. Taking a look at the next problem. So we have a saturated solution of NaNO, or we have a solution of NaNO3. So first thing is I need to find the curve on table G, so I know what I'm looking at. So here we go. Now, it says it is saturated. So we're starting off on the curve, and the starting is at 50 degrees Celsius. So at 50 degrees Celsius, we are actually on the curve. So that's where we are starting. So if I think about this as a have, need, do, okay? So what I have in the solution at 50 degrees Celsius, it looks like I have, 115 116, so I will round to 116 grams of NaNO3 in the solution, and it's at 50 degrees Celsius. That's my starting. So that's where I'm starting. Now, according to the lab, what needs to be done is that we need to decrease the temperature to 24 degrees Celsius. So 24 degrees Celsius. So in the lab, right, we are moving it. Well, it says how much solution will precipitate out. So take a look here. We want to end up on the data point, or we want to end up on the curve, right? So if we allow the temperature to cool down to 24 degrees Celsius, right, that ends up way above NaNO3's curve. The water cannot still dissolve all 116 grams. There's too much. So at the new temperature, too much solute, okay? So precipitate. So precipitate, this is a solid that falls out of solution. And it's not like a brick. It's a powdery solid. So just remember, it's like a powder. And at this point, that powder is not soluble. Not because it can't dissolve in the water, it's just that the water's oversaturated. The water can't dissolve anymore. So a powder that collects on the bottom of the container. So here we go. So what we actually only need in the solution looks like to be around 92 grams of NaNO3 at this new temperature. So if you calculate the difference here, 116 minus 92, gets us to around 24 grams of NaNO3. So we can so 24 grams of NaNO3, it precipitates out, and we can actually remove it by filtering. Yeah, we can pour that mixture into a filter. All of the dissolved NaNO3 will pass through with the water, and the undissolved portion will stay on the filter. So from that data point to here, this is what will precipitate out of solution, and we can remove it through filtration. Last question here. Determine the mass of NH4Cl. So I've got to go find this. So there's NH4, and this is the line outlining it in orange that I'm going to highlight because that's what I got to focus on. It says determine the mass of NH4 needed to make a saturated, so that means we need to be on its curve, that orange line, saturated solution in 500 grams of water at 50 degrees Celsius. Well, here's the thing. Table G is based on 100 grams of water. So here is my table G. Table G is based on 100 grams of water. And at 50 degrees Celsius, so it's right about here, 100 grams of water at 50 degrees Celsius can dissolve around 52 grams of NH4Cl. That's table G. Now, the problem, the question, it's still at 50 degrees Celsius, so it's the same temperature, but it's based on 500 grams of water. Well, 100 grams of water can dissolve 52 grams of the solute. If that's true, then we would expect 500 grams of water to dissolve how many grams? So X grams of NH4Cl. So the math is easy. 500 is 5 times larger than 52. So 5 times 52, and that gets us to around 260 grams of the NH4Cl can dissolve. So my answer here would be 260 grams of NH4Cl in 500 grams of water.